getting more difficult as we go. Don't stop on me. It's not prime. First, look for a greatest common factor. Just something. Yes, 4 goes into both of these. Are those two numbers perfect squares?
Yes.
As long as the exponent of a variable is an even number, it's a perfect square. If it's x to the 10th power, even though 10 is not a perfect square, it's an exponent. Because x to the 5th times x to the 5th gives you x to the 10th. X to the 8th power is a perfect square. Because what gives you that? X to the 4th, x to the 4th. Yes?
What if in the original problem it was 8y to the 4?
Then when you took out the 4, you'd have a 2 left right there and you'd have to stop.
So it'd be prime in that case.
No, it wouldn't be prime. You'd have to take the greatest common factor out. Okay? And then from there, you couldn't go any further. But you have to, if there is a greatest common factor, you have to take it out. Now here, x squared times x squared gives me x to the 4th. Y squared times y squared gives me y to the 4th. 1's plus, 1's minus. Am I done? Why not? I still have the difference of 2 perfect squares. So I've got to take that factor and break it apart. Okay? Because it says factor completely. As long as you can keep going, you keep going. Now this is done. This is done. But x squared minus y squared can be factored down into x plus y times x minus y. So you've got to keep going.
So what's the answer? Why do you put that?
Why do I put what?
I mean, why you keep x squared plus y squared?
Because this is a piece of my puzzle.
Don't factor that down.
I can't. Because remember, if it's a plus sign, when I put it back together, I'm going to end up with a middle term in here. And I can't have a middle term. It's got to be the difference of perfect squares. If it's the sum of perfect squares, don't touch it. There's nothing else you can do with it. But as long as you've got the difference, then you can keep going. So basically what we've created is a 1, 2, 3, 4-piece puzzle. Okay, we got 4 pieces to get all the way back to this big picture. And you've got to have all those 4 pieces accounted for. Because you want to be able to put it back together and end up with 4x4 minus 4y4. Okay, take out your homework from the weekend. Page 242, you had 21 through 30. I'm going to go ahead and give you the answers to the evens so that you can check yourself. And then you can ask me any questions that you had. So you had the odd answers. Here are the even answers. Remember that the order of the groups doesn't matter, just so the groups do consist of these things. Okay, check your even answers. And then if you have any questions, we'll go over them.
I did to 38.
You did to 38.
Yeah.
Well, that was hard because I didn't teach y'all how to do that yet.
And that's why I was.
It said 30 on the board. Did it say 38 on the website?
No, you changed it like before the end of class.
Is that what it was? Y'all probably, okay.
Change it right now.
Sorry about that. All right, well, through number 30. Clint.
Can you work number 26?
Yes. So 26 is 12m squared minus m minus 6. First, look for a greatest common factor, which there is not one. Okay, so we've got to take into account our little cross multiplying thingy, right? Okay. When you have several factors, I'm going to give you all a little hint on how to choose your factors. Because for 12, we've got 12 times 1, 6 times 2, and 3 times 4, right? And then for 6, we have 6 times 1 and 2 times 3. Figuring out which ones to use, it's helpful to look at this middle term. If you're going to be subtracting, or if that middle term is a really small number, then most likely you're going to be using the factors that are closest together. Like instead of 12 times 1, you're going to be using 3 times 4, because those are only 1 apart from each other. Instead of 6 times 1, you'll probably be using 3 times 2. But if this middle number is big, say this middle number was 20, okay, then most likely you're going to be using some factors that are farther away from each other, because you're going to be needing bigger products that add up to bigger numbers. So, because this middle term is so little, I'm going to start with 4 times 3 for my factors of 12, and 3 times 2 for my factors of 6. Now remember, when you cross multiply, if it doesn't work out the first time, it does not necessarily mean that your factors are wrong. They could just be in the wrong spot. Okay? But let's go ahead and do this. When I cross multiply here, I've got 8m. When I cross multiply here, I've got 9m. Now I need these two terms to subtract to give me 1. Well, they do. But I want to get -1. How would that happen? So my first group has the minus sign, and my second group has the plus sign. Remember to check yourself. Put it back together. That's 12m squared. This is positive 8 minus 9, which is -1m. And then we've got -3 times 2, which is -6. All right? Don't forget to check. Any other questions on the homework? 28? What do you have?
Yeah, I have that.
Okay, I haven't taught you that yet. That's cubes. We haven't learned that yet. Okay? 28. 28, you had to look for a greatest common factor. 3z squared plus 24z plus what? Always start by looking for a greatest common factor, especially if there's a number in front of that z squared. Does 3 go into all 3 of those numbers? Okay, we got to know our multiplication tables. Does 3 go into 24? Yes. Does 3 go into 45? Yes. 15 times. Okay, so we've got z squared plus 8z plus 15. All right, so 3 is a piece of my puzzle. Here I've got z times z to give me z squared. 5 times 3 to give me 15. And do these two add up to 8? Yes, if they're both plus.